once again one of my favorite guests, Graeme Rocher, the founder and one of the main committers to the Micronaut application framework. And today we're going to talk about Micronaut and message-driven microservices, how to build them with Micronaut and Kafka. And I think this will be a very interesting session. I like Kafka and I have questions about that, and I will certainly learn a thing or two myself. That all being said, Graeme, hi, how are you doing?
Good, great to be here again. I'm sure we'll have a lot of fun. It's an interesting topic, and yeah, everybody loves Kafka and everybody loves Micronaut, so the two combined should be a lot of fun.
Do you think in general, so Kafka is the event streaming platform, right? And it has different kinds of APIs, but it can serve as a database, it can serve as a distributed log, and it can do different things, right? And then different projects are using even, dare I say, different implementations of the like backing platform. I know there is a Kafka, which is written in Scala mainly, and there is also some software that implements the same protocol is written in C++. I think there is a Rust version as well. I don't know, like cloud platforms implement their other things. So what do you think is the most important bit about Kafka and why it is so popular? Just before we go into the...
Well, I think that it solved a very real problem that a lot of, originally it came out of LinkedIn, and they had really real problems with existing kind of messaging systems in terms of pushing large amounts of data through a kind of data lake, data streaming platform. So I think, the innovation in Kafka and the reason why it's so popular is because of that architecture innovation of essentially, a lot of people, they talk about Kafka where they first introduced Kafka, and I see this a lot of developers. It's like, they think it's like a replacement for JMS, and it's not really that, right? It's really much more, data lake, data stream, real-time analytics data platform, essentially. So if you're using, Kafka just for like point-to-point messaging, you're probably like overkill. Actually, probably like JMS, it's like absolutely fine for that, or a RabbitMQ or whatever kind of messaging system you use. But if you're dealing with large amount of data in a kind of event streaming way, like for example, I guess the LinkedIn use case was they wanted to track what everybody was clicking on the website and ingesting all that information and analyzing it in real time, and needed a completely different way to think about data essentially and process it. So yeah, it's certainly a very interesting platform, and yeah, you can tell it's innovative and a whole new market because of the, when you have a technology that's being copied or replicated by others in different ways, you've created something pretty compelling, right? So and that's why you see things like, I don't know, you mentioned the C++ version. I think there's something called Red Panda as well, which is written in Go. Which is another kind of Kafka.
I think Red Panda was in Rust, and then vectorized IO was C++ or something, or the other way around.
Yeah, I cannot keep up anymore. And the new Kafka implementations are like new JavaScript frameworks.
But in a sense, all of them would, like, for example, Micronaut applications would work with all of them because it communicates to the backend system using the client, and the driver and the wire protocol is the same. So essentially your application doesn't have to change because of the system. Very good. So we can call everything there on the backend side, everything we're going to call it Kafka. Kind of like sort of we generally call everything that's someone else's computer, we call it cloud, right? So there will be an abstract Kafka out there. Right. Okay. How complex do you think it's, like, is it complex to start with Micronaut and Kafka, or how
no, it's super easy. I mean, actually the complex bit of starting with Kafka is generally Kafka itself. I think they have it's they're improving that situation with the newer releases, allowing you to kind of eliminate the need for Zookeeper and so forth, to kind of act as the way to kind of balance and rebalance nodes and so forth. In the newer Kafka versions in the future, Zookeeper is going to be an optional component. Other implementations like the Rust one you mentioned and so forth actually don't have the Zookeeper requirement, and so forth. So, but you can spin up Kafka inside Docker containers like any other component. You can use test containers to spin it up inside your test integration tests, like anything else. I think writing tests with Kafka can be a little bit challenging because you have to kind of involve testing tools that are able to kind of deal with its asynchronous nature. But that's not really any different to any kind of messaging based integration testing. I think there are nice testing tools for both Spot Container 5, such as Waitility and so forth, for doing those kind of verification. But in terms of getting started with Micronaut and Kafka, it's like super easy, right? And it's all integrated into Micronaut launch, and we have support for both, creating Micronaut applications that are regular REST applications, REST microservices and so forth that serve as kind of Kafka producers of information. And then you can also build kind of headless message-driven microservices, right? They don't have a HTTP endpoint at all. They're just like message stream listeners. They don't even expose a port. And that's your typical message-driven microservices where they're just literally listening to Kafka messages coming in.
Very nice. Very nice.
Yeah.
Would you like to show one of those, or how to create one of those, maybe?
Sure. Yeah. So this should be fun. Okay. So I'm going to just click out of that quickly, and so I have the Micronaut.
Can you share your screen,
installed.
Please?
Yeah, that's a good point. Good catch. So that you should see the VS Code now. Yeah, in theory. Don't disturb me, kind of thing. Okay, so I'm using VS Code, but you can use this. This is our tooling that we've been building, and I think I demoed it a few weeks ago on the same stream. But you can use any tooling that you want. And the way you get started, so I'm going to get started with, first of all, let's create like a regular microservice with Micronaut that is going to be a Kafka producer. Let's call it like just book producer or something like that. And what you can do is choose the Kafka feature when creating your application. And we have also support Kafka streams. But in this case, I'm just going to do Kafka messaging, and you click OK. And choose your build tool, unit testing framework. And then we can output to a appropriate location. So I have demos outputs directory here, and I'm going to create my project and import it into VS Code, which shouldn't take too long. And now I have
for people who missed the last stream, the widget that Graeme used for creating the project is a VS Code extension for Micronaut, and that was pretty smooth. I like that very much. So it mirrors the Micronaut.io/launch UI, right? So you can pick all the things that you can pick there. You can pick from the extension. Very nice. You can create project without leaving your IDE.
Exactly. Yeah. And IntelliJ, for IntelliJ users, it has the, we have IntelliJ has the same integration with Micronaut launch. But it's nice that we have it in VS Code now, which is really cool. So yeah, that's that's how you create a project that can basically produce Kafka messages. Now, I actually have in another window here Kafka running, Zookeeper, and Kafka server, and I've set it up with a single topic that's going to like have two partitions. So the way Kafka works is you can kind of partition data, and many listeners can essentially participate in a consumer group of listeners, and you send messages, and it can balance between essentially balancing the load between your different Kafka backend nodes. But before you can actually start like building Kafka consumers, you actually have to produce some messages. So that's kind of the first thing I'm going to look at doing here. So I'm actually just going to do it on startup. So I'm going to make my application class a bean by applying a bean-defining annotation to it. And I'm going to add a startup event here, startup event listener. And within this listener, I'm gonna send some Kafka messages. And the way Micronaut enables you to send Kafka messages is pretty slick. So what I'm going to do is I'm going to create a template. What is it? New from template. I'm going to create a new book client.java, and it's going to be in my package com.example. And this is going to be a book client. And we're going to make this a Kafka client. And that's all you pretty much have to do to make an interface a Kafka client. And what you can then do is specify a topic you want to publish messages to. So let's call it books. And we're going to send the title of the book. And now that is all you have to do to define a Kafka consumer in Micronaut. So I can inject this into my application class. So, and generate a constructor like so. And then I can come in here and send the title of a book, for example. There we go. And that's a basic Kafka consumer implemented with Micronaut. So you may be wondering, you haven't seen any kind of reference to the Kafka Producer API. So you can, in fact, also just inject a Kafka Producer. So this is a very slick way Micronaut provides to encapsulate all the necessary logic to send messages without you having to like handwrite that by yourself. But you can actually also do stuff like this. You can say inject Kafka client, and it's the name of some Kafka client, and inject a producer directly, right? That you have to supply the arguments and so forth. So we do provide support for directly injecting a producer, but the integration that like basically implements it all for you is part of the opinionated way, that Micronaut supports, of basically, doing all the heavy lifting for you. So I have a Kafka Producer now. So what I'm going to do now is I'm going to go back to my Micronaut tools page, and I'm going to create another new Micronaut project. And we're going to use Micronaut 2.55. And this time I'm going to create a Micronaut messaging application. So I'm not going to select normal application. I'm going to create a messaging application. And what this does is it creates a headless application that actually has no server, right? So when I select this, and then in this case, what I'm going to call it is book consumer. And once again, we go through the steps. We choose Kafka as the messaging type and build tool. And we can create another project that's going to serve as a Kafka consumer, right? So now we have two projects. One is the consumer and one is the producer, right? So in this project, now if I run this project directly already, it will probably just like it will start up, but it gives you a message down here. I don't know if you see that down here. Startup completed, but there are 0 active message listeners, right? Because I haven't like defined any kind of message listeners. So what I can do is basically define a new book listener .java in my and what I'm going to do is call it book listener like this, and this is going to be a Kafka listener, right? And it's going to listen on the books topic, and it's going to receive the title of the book, and we're just going to output now, and it's going to receive book like that.
Right.
Okay.
So just to confirm my sort of silly suspicion here, right? When you say it will receive the title of the book, it will receive the whole message, which is a string, and we just know that it's a title. So it's not like we are sending like some sort of a JSON structure, which is a book, and then somehow map it based on names, right? It just
no, we will get to that. That is, all of that is possible, but essentially, yes, when you specify a string like in this manner, it assumes you're going to receive the raw message content, and you can make it a byte array if you're receiving like data that's not textual, right? So it's literally anything, but basically, yeah, this is the raw body. Now, Micronaut Kafka does support like multiple different arguments that serve different purposes, and if you did have different arguments, what you could do is you could explicitly annotate this argument as the message body to provide the kind of to disambiguate which one is the message body if you were supporting multiple arguments. In this case, I don't need to because it's just like the default, right? Okay, so basically, yeah, I have now I can run this, and what we should be getting now is a single message listener that is subscribed to my Kafka topic, which is great. Now, one of the things that you may want to do, and you typically want to do in production, is on the Kafka listener, you will probably want to assign a shared group ID to all of the different Kafka listeners that you operate, if you operate multiple of them. This is so they participate in what's called the same consumer group across multiple listeners, essentially. So if we come back to my other application now and fix my compilation errors and import that again, because I seem to have broken something around here. So basically what this is going to do is when the application starts up, it's just going to send a message, and let's run it and see what happens. And maybe the demo gods are with me, maybe they're not. Who knows? Okay, so the application started up, and if we switch to the other one, you can see down here, right at the bottom, that we have my system out information. So my Kafka consumer basically received the message. One application is sending it, the other application is receiving it. So that's a very simple, trivial example of the most basic integration with message-driven microservice, strings going back and forth, and so forth. Now, obviously, Kafka is used for a lot more complex use cases than that. So, so one thing that you may want to do, and I'm just going to stop this app, is Kafka allows you to scale messaging through the use of a key, right? So, so for example, imagine I had a key here, which is the author of the book. I could denote that as the Kafka key in my client here. And then I can come back to my application and send a whole bunch of messages here, you know, for different authors and books. So maybe I had, you know, this is by Stephen King, this book, and we have another book by Stephen King called Shining, and then maybe we have James Patterson, Along Came a Spider, you know, what other authors are there? Who knows?
I think there's a great book by the author that I don't really remember, called Graeme for Dummies. I think we have to. Let's say Graeme wrote it.
Let's just say that Graeme for Dummies, right? Okay, so there's a whole bunch of books, and maybe we have Joe Blogs in here. You wrote whatever. There we go. Okay, so we're gonna send 5 books on startup using the author as the Kafka key. So the key thing here is now, if I go to terminal in this other application, and I start a second instance. So now I've got one instance running already, which is up here, and it's like this thing. And I'm starting another instance. And what's going to happen here is it's going to start another consumer in a different JVM, and it's going to perform a rebalance of all the consumers and assign to a partition to essentially another instance of my book listener. So now I've got 2 instances of my listener application running, 2 JVMs, independent JVMs running, both participating in the same consumer group, listening for different watching different partitions. And what Kafka does is basically automatically partitions on the producer end outgoing messages based on the Kafka key. So it'll look at the number of partitions and perform a hash on the Kafka key that you provide, and basically select one of the consumers to send the message to. So if I come back to my application and we run it again, what we should see, if I just focus my debug console, so it's sent all that data. What you should see is that you can see that some of the data went to this consumer. Looks like the books by Stephen King basically landed on this consumer here, and Joe Blogs, I think it was, who wrote whatever, received this data. And if you go to my other consumer, you can see that the Graeme for Dummies by Graeme landed on this consumer. Down here, you can see down here, and Along Came a Spider by James Patterson arrived on this consumer. So obviously you can keep adding consumers to your consumer group. You can add like 10, 20, 30, 40, and it will basically partition the data and scale out automatically on the producer end, allowing you to deal with the massive quantities of data, right? And that's the real, you were talking about like why is it so popular? Lots of companies have big data problems, and this is the kind of thing that Kafka gives you, right? This ability to automatically scale it.
Right.
So that,
can you show the producer for a second?
Sure.
So here the partition key is not a part of the message, right? So it's just
that's right. API, so we annotate Kafka key with the author to tell Micronaut what is the key to use for partitioning the data when sending the message.
Right.
And the only data that actually gets sent is the title of the book.
Right. Very good.
So, but having said that, if you, on the consumer side, on this side, you want to receive the key as well, you can type in here the same thing, Kafka key, and give me the author. And then, in addition to basically in addition to the title, you will receive the author of the book, right? So that will happen automatically. So I can say this, and basically I will probably have to restart my instance here, and I'll probably have to restart the other instance. And basically, yeah, those will now, if I come back and send my messages again by restarting my other application, you'll see that the authors start to appear in the output, right? Because now we can actually retrieve the key, which is probably useful in a number of different scenarios. Now, one important thing to realize here as well is that the Micronaut will automatically use the types of the key and the body to automatically select the deserializer and the serializer. So Kafka has this notion of like SERDs, serialization and deserialization, for both the key and the value. And because we're using strings here, it's automatically going to use the strings deserializer for this consumer. And on the other side as well, it's automatically going to use the string serializer. However, that is customizable. You can identify this particular client, and actually giving the client an ID, for example, books consumer, you can call it. Giving the client ID is useful because that information will actually appear in things like distributed tracing information and so forth, which can be very useful. So identifying the client by a particular name. And then what you can do is you can come into your application configuration, and I can say Kafka consumers, and I can put that ID in there, whatever. And I can customize the key deserializer or the key, that's actually the consumer, sorry, this is the producer side. So again, you can basically say, I want to use this particular serializer for this key when serializing the data, right? If you wanted to send it in some other serialization format, right? So Micronaut doesn't take any of that power away from you. And like, if you want to get low level, like I said, and actually inject directly Kafka producers, then of course, that's completely possible as well. What Micronaut is doing here for you is taking the burden away from you of like the repetitive nature of like exception handling and writing producers and so forth. So you mentioned, the fact that we're sending like just string data, right?
Yeah, it looks awfully stringly typed to me. I mean, like, I understand how you can build systems with this, right? But yeah, like you have different applications. They you have to match what is a string author, what is a string title. That of course you can cover that with tests and whatnot, but like that seems like a a very expensive mistake waiting to happen in production somewhere.
For sure. And that's why, you can, for example, by default, I can say, I'm going to, create a book.java class here in the package com.example, and this is going to be class book. And what I can say is this, Micronaut actually allows you to like serialize and deserialize POJOs like this into JSON by annotating them without introspected in a completely kind of reflection-free manner. So I can say, this is the title of the book, and maybe you can even include the author, for example. In the data that's being sent, we can generate a constructor for that and generate some getters here. And basically what we can do then is come over to our client, and instead of sending this just string, we can send the book. And come over to my application here, which is clearly going to fail now. And what we can say is, instantiate some books to send over. I can't remember which order the parameters were in. So yeah, something like that, and etc. Let's copy this over there and send some additional data for each. Probably, we would want to kind of refactor this into variables, etc., and write reasonable code, etc. And basically, yes. Oops, what have I done there? Oops. Yeah. So James Patterson, along came a spider, etc. And basically we'll just get rid of those because we've probably got enough data to demonstrate what we're, instead of typing that all up. So now we're sending book objects over over our messaging platform. So we can model that using our entity classes here. And on the other side, we can do the same thing. We can define a book class on the other end. And this could be like a shared library between the two projects, the producer and the consumer, rather than being copying and pasting like I'm doing in here. And we can receive the book like as an entire thing, and do book.get title, etc. And book.get author, etc. So that's basically how you can do that. And now I will have to restart my instance here. Probably the other one I'll just kill for the moment, since we've already demonstrated multiple consumers and all that business. And then I can restart this and send the book JSON, and you can see that that works as well with the data coming back this time with an entire kind of Pojo object representing my data model. Now, there's also, in addition to that, there are other ways to do this. So Kafka has this serialization format, which is typical, called Avro, where you can define this kind of schema. And you could integrate with that, defining an Avro schema, and Avro has build tools that you can integrate with your Gradle build or your Maven build to generate from the schema the equivalent Java class. And I believe there's things like schema registry, and there's a lot more possibilities that are probably beyond the scope of this demo. But essentially, yes, you can. By default, you can serialize it over JSON, which is very handy out of the box. That it just works, right? So hopefully that covers that particular topic.
Yeah, that's sorry. That is a very slick and elegant way of using. I think I've tried some time ago creating some Kafka clients with Micronaut. That was, I think, last year or something, and I think something changed in the API, but I like this, right? So it's very intuitive. It's very declarative way of describing your client and your listeners. Yeah, so it all looks very, very good.
Yeah. So the nice thing about this as well is how it integrates with the rest of the framework, right? So So, you can do things like say, this should not be blank, and null that, and maybe the maximum, the size max should be 100 for the title, or something, whatever. Provide your kind of validation rules, and then on the client side, you can say, make sure this is valid before it gets sent out. So that's one of the reasons why, rather than working directly with the Kafka consumer API, we can provide like slick validation integration, for example. You see what I'm saying? So that you're validating the data before it goes up over the wire.
Right. Yeah, this is definitely interesting. And we had a question earlier, and I'm not sure whether you plan to cover that a little bit more in more detail, but Martin is asking, so when you created the wizard, created the projects using the wizard, there were two different options: Kafka messaging, which is what we currently looked at, and there was also Kafka streams.
Yeah.
Can you maybe elaborate a little bit on the difference? What are those, and what's
so Kafka streams Kafka streams is a separate library that lets you define a whole topology and transformations between one stream, the inputs and outputs, and it's really quite an interesting product that actually many we talked about, like other implementations of Kafka, like that don't support, right? So there are a lot of features of Kafka proper that are supported. One of them being Kafka streams by Kafka, but are not supported by other cloud providers or whatever. Kafka streams is a different thing. Basically, you can, if you go to the Micronaut Kafka repository and head over to the docs, what you can do is essentially define your Kafka streams in Micronaut and dependency inject them and integrate them with the framework. So this is the canonical counting the words stream that is, from the example documentation.
Can you zoom in a little?
Where you define, there we go. Where you define like K stream and K tables and group by and that kind of thing. So it allows you to integrate the creation of streams into Micronaut. And because this is just a bean, you can dependency inject components into it if you wanted like some kind of database integration and to participate in part of the definition of your stream or for whatever reason.
Sorry, can you zoom in, please? I barely see the text. I am sure the stream doesn't see the text at all.
Let me.
Okay. Yeah.
Hold on.
Okay. Yeah, much better. Thank you.
Make it bigger. So this is allows you to essentially define K tables and K streams and so forth, which is an additional extension that not every application uses, right? Again.
Right. So a Kafka stream is sort of like a full application consumer that kind of subscribes to certain topics, and then you can declaratively describe what logic should be executed on the new messages. For example, you can group things and then count things, and then you also output the result of that computation
to another topic, for example,
back to Kafka, right?
Yeah, exactly. So it's a way to declaratively define transformations and so forth, which a lot of enterprise integration patterns and so forth. You basically transform data into the format that you want and then spit it out to another topic. Exactly.
That is very cool because that allows you to offload the computation from the machines that are running Kafka, like from your cluster that has to be like highly available, and probably like CPU is quite expensive there, right? You can offload the computation to your clients, which could be disposable and cheap, and then you sort of just do the computation, write it back, and since it's a distributed thing, it probably somehow magically works out in the topic. I'm sure there are also some issues that you can stumble upon if you do this incorrectly. But that sounds like a powerful API.
It is, yeah. It is. So anyway, that's why we have a separate module for it, because it's an optional additional dependency, and you can choose which one you want to use. Okay, so in addition to that, you can going back to the application that we're building here, you can see that the other nice thing about this declarative approach to defining your producers that Micronaut provides is the ability to define kind of reactive asynchronous types. So for example, you can basically put like completable future on here, and basically do asynchronously, or you can say you can define a RxJava completable to allow reactive handling. Micronaut's default server is non-blocking based on NetEase. So if you're like sending messages and so forth, you can do that in a kind of non-blocking way, which the Kafka Producer API allows, but Micronaut does the effort of making sure it integrates nicely with reactive programming and so forth, which is pretty cool, I think, as well. And the other thing I want to point out as well is there's a lot of different options on the client's annotation. So this is the kind of ID, but you can basically control properties and all sorts of things. Like, for example, the producers let you configure how many times to retry. And a very interesting option as well is batch. So when you set batch to true, Micronaut will essentially alter the behavior to, I think that's the ID. When you set batch to true, Micronaut will essentially alter the behavior if you define a list of book. So by default, that should be a. So by default, the behavior without batch set to true is that it will serialize the list to a list of books, like in one, serialize the whole thing essentially, and send it, right? Which may not be the behavior that you want. When you put batch equals true, what it changes is that the producer will iterate over the books and basically batch up the producer record and send the individual books in one go, essentially. So that lets you control, instead of in this example here, where I am doing send, you can instead, basically create a list of book, like so, and you'll probably have to like split them up into Stephen King's books and the other books, and basically batch them up under a single key, for example. So you do stuff like that and send them all, and then you would have another array for all of James Patterson's books, etc. And maybe would have many of those. You would send them in a big batch.
Right.
Producer will batch those up and send them.
They will still come to the consumers. They will still come as individual messages, right? Because those are still individual messages. They're just batched on the sort of protocol level.
So they're batched. The producer will send them in a batch of producer records.
Right.
And then you can switch over to the consumer side, and you can say, I want this consumer to receive receive a batch of books. And again, you can do the same thing where it can process in batch a whole bunch of books in one go, essentially, which is really handy. Now, if you had like a mix of methods, like some methods processing a single and some processing multiple, what you could do is add this customization at the method level. So I can say, this one, only this method is doing batch processing of a list of books, and that would essentially be the same thing. And obviously, right now, I have to say, let's just do books.size. And author, for example. Okay, so let's restart this consumer, which is going to receive a whole bunch of books, and go back to our producer, which is batching up all of those things, and see what happens if the demo god is still with me.
Oh, I'm sure it's gonna.
Oh, they're not.
Yeah, I almost said that it is gonna be fine.
Required argument. Well, I think yeah, because all the arguments have to be batched, right? So because each entry will have an associated key, essentially.
All right.
So hopefully, see, no, I haven't done something wrong here, probably. Anyway, I will figure that out at another point. Let's move on to something else. I know that does work, but I'm obviously doing something wrong here. Okay, so
that doesn't matter. The API looks understandable, and I think that's what matters, right? The particular application doesn't have to actually run. It's we're looking at the higher level picture.
Indeed.
Very cool.
Yeah. So I'm going to roll back those changes for a moment, because I'll have to figure them out later. And I'm going to move on to some other aspects of Kafka, the Kafka programming model. So let's just roll that stuff back and go back to sending the individual books for a moment. There we go. We're going back too far, I think. Okay. There we go. Okay, so let's restart that. Okay, send the books. We have to restart my listener, I suppose.
A quick question: how would you test this system? So you have two different applications, right?
There we go.
And Kafka, you definitely can kind of defer to like the Kafka lifecycle to say test containers or something, but then still you have to run like two different services for this even simple like loopback. Would you like merge them or?
Yeah, so there's different ways that you can. I mean, in general, you can, in the one application that's producing the message, just assert that the messages are going out. And in the other application that's receiving them, just assert that, but if you want, a full-scale integration test, a good way to do that, and we're doing that recently on a project that we're working on now, is to use test containers to spin up publish each microservice as a container itself, and then use test containers to spin up those containers and link them to a single Kafka instance and have a full end-to-end integration test, essentially. So that's, one of the things that you can do. Okay, so one of the things I wanted to mention as well is some of the configuration options regarding offset strategy. So one thing in really important setting with regards to Kafka listener attestation is the offset strategy. So the default offset strategy, if we look at the Kafka listener notation, is set to auto. And what that means is once this method completes execution, Micronaut, the listener will, Micronaut will commit offsets on your behalf synchronously. So it will essentially commit the offsets, unless an exception occurs, in which case the offsets will not be committed, and that the listener will have a chance to process that same message. Right. The act of committing offsets in Kafka is kind of like acknowledging a message has been received in kind of traditional messaging systems. But what you can do is you can say offset strategy, and you can customize that. So depending on the way your application, like the importance of the data to you, like for example, you could say offset strategy async. And what that'll mean is it'll execute this method and then asynchronously commit offsets at some future point time in the future. If that's fine if like the data is like not like hugely like critical or important, right? Or you want high throughput in your listener, because you can basically will on your behalf asynchronously commit offsets. Another option as well is things like sync per record. Like if you're really paranoid, obviously the default strategy is sync, which means that for a particular poll loop and a particular batch of records, it'll commit at the end of processing those. But if you want to like commit more frequently, so obviously after each message has been processed, you commit. Obviously that has a higher performance overhead, sync per record of committing offsets. And then another common thing is to just disable offset commits completely. And in this case, what you have to do is control that yourself. So I can actually inject a what's called a acknowledgement in Micronaut's terms. And what I can do with that acknowledgement is I can perform whatever processing I want to perform, and then I can call act on it, right? And this is a kind of abstract interface that's part of Micronaut messaging application API. So that it's common whether you're using RabbitMQ or whatever messaging system. But basically, underneath the covers, this call to act will commit the offsets once the message is being processed. Just going to restart that, and you'll see that in action. But the advantage here is clearly that what you get is basically you can control how and when offsets are committed, and be in complete control of like the behavior of the application. So if you can implement your try-catch handling, or maybe you want to acknowledge only after a transaction has been committed. So you write to the database and then you acknowledge, or there's lots of many potential, or you want to pass this reference somewhere. So you basically control when the offsets get committed, which is really useful. Now there are other ways where you can essentially actually pass in the entire consumer here. And so I can actually inject the actual Kafka consumer object in here as well, if I want like complete control, and do Kafka commit async, commit sync, and there are ways in Micronaut Kafka where you can essentially inject any of the different components. For example, you can essentially inject into the receive method the offset, the partition topic, and perform the commit operation directly yourself, right? So the point of Micronaut Kafka is not to like take away power from what you're able to do. If developers want to get like really low level and write their consumers, and directly control the Kafka consumer API. That's completely possible. It's what the point of Micronaut Kafka is to make the kind of common case easy, right? I think that's, in general, what a lot of developers are after is like, make the repetitive common tasks dealt with automatically by the framework, but then let me get down and really, to the APIs that I need to get to. Don't hide those from me, right? A lot of developers have.
Absolutely. This is the main premise of the convention over configuration, that you have
Right.
sort of an opinionated high-level API.
Yeah.
While we're here, there is a question from Optimal Monkey about if one is sending millions of messages in a batch, can those be produced and consumed as Java streams rather than arrays of lists or arrays or lists?
They can be.
You meant, sorry, and I've just, if this is my understanding, you mentioned that you can do the reactive streams integration, right? But
yeah,
is that this sort of thing, or?
So you can actually define reactive types here as arguments. I can receive a single book and so forth. But it should be noted that Kafka consumers are like inherently single-threaded, and the poll loop actually doesn't let you perform operations that are like on another thread. Kafka will actually error if you do some work or interact with the consumer from a different thread that's outside the poll loop. But you may want to like compose operations and so forth. And in terms of like injecting other objects like, I don't know, streams or whatever, you got to remember as well what I referred to earlier is that you can customize the serialization and deserialization of message body to your heart's content, right? Simply by coming into application.yaml and saying, for my consumer, I want a custom value deserializer, and you can deserialize it into whatever you want, right? If you choose to do so.
Right. So in short, if I understand this correctly, there is no high-level API to use streams there, but like you can easily do that yourself.
Yeah, I mean, and also, if you enable batch receiving, which does work, it's more I did something on the demo, but you can obviously pass a list, which you then can just call .stream on if you wanted to. So there's lots of different ways to structure that if you want to. And in regards to getting like low level with the API as well, another thing that a lot of folks want to do is you can actually make this listener implement what's called consumer rebalance listener. You can make any listener in Micronaut Kafka implement this interface. And what that means is you'll get callbacks from Kafka saying on partition revoked, on partition received. And you can, in addition to that, implement the consumer aware interface from Micronaut. And what that will do is, in this case, it's the arguments are like the arguments are the key and the value type. And with this interface, you can get hold of the actual, you'll get a callback to receive the actual consumer instance here, which you can assign to a local variable somewhere. And then once you have the Kafka consumer, you can manually assign partitions. For example, if I had a consumer here, I could say, take my consumer and seek to a particular offset position, or seek to end, seek to beginning, and really control exactly where you want to start streaming to. Like I said, the point of Micronaut Kafka is not to hide any of this ability that you have with the normal Kafka consumer API. It's to enable you to get to those things and do manual partition assignment and handle revocation and all these kinds of things. Yeah, so that's going to roll that back. Okay. So one final thing I wanted to demo as well is the ability to like relay messages. So we were looking at like Kafka streams. So it's kind of possible to do that in Micronaut as well with the kind of simple mechanism, which is maybe not as powerful as stream and K-table and all that business. But what you can do is in any listener as well, is you can say on a listener, send to pages, for example, and maybe you can like return like some kind of result here. So I could have another class here. I'm just going to put it as an init class. Book pages, and we'll make it introspective, like so. And maybe we'll have, you know, the title of the book and the number of pages, and we'll generate a constructor from that and generate some getters. This is all going to be a lot easier in Java records as well, by the way, which I'm not using Java 11, so having to do that. But essentially what you can say is, imagine you had some kind of logic here where you want to return the number of book pages. So you want to receive the book, and then for that particular book, and probably I'll get rid of this manual acknowledgement just so we can focus on this particular demo. And you want to say something like compute book pages for the book, and you have some algorithm that's doing number crunching and whatever else to compute the book pages. That's going to like turn my book pages and receive the book, and we're going to like do something like return new book pages, get title, and there's some complex algorithm in your system to compute the number of pages of this book, but we're just going to hard code it to 500. So you can return a value from a listener method, and you can say, send it on to the pages topic, right? Once you're done with it. And the pages topic could be running on another like message listener somewhere. In this like little demo, we're just going to say, I'm going to add my pages, and it's going to receive pages, and it's going to be my book pages. And we're going to output system.out line pages equals, and there we go. Okay. So yeah, this is a completely non-realistic example, but you know, you would have simply a separate microservices that process data. Basically, it's going to receive this, do some computation, and then relay it onto a completely different topic. So let's restart that and go back to my my application that's sending all those messages, and send those messages again. And you can see that the book gets received, gets processed, the pages get computed, which are always 500. That's it. Possible to relay messages to a completely different topic through the use of send-to, which is, I think pretty cool.
Yes. So if I think about this, if we have this messaging application that doesn't have any endpoints, so it's a completely like standalone instance of an app, it runs, it listens to Kafka topic, it gets the messages, and it has to do something, right? There has to be an outcome. Otherwise, it's just heating the universe, which is not what we want more of. Yeah, and this looks very natural. So you just compute the data and you send it back to Kafka, which mirrors, I think, mirrors most of the integrations with like various clouds as well, right?
Yeah.
You'll have some sort of message handlers that could be like HTTP request response, or you could have I don't know, like Kafka request response. So this is also kind of fits into the same mental picture, how the application fits into larger architecture. That is cool.
For sure. For sure, yeah.
Send to. Interesting.
Yeah.
Is there any, like, do you have any hints in the Micronaut or in any the plugins or anywhere that would say like, oh, it looks like you're doing this messaging application. Don't forget to add the send to thing or return things.
No, no. In general, it's commonly known as RTFN.
Yes. Common, of course. You have to, like, yeah. If you do things well, they will work well, right? If you, that's to have things that work well, you have to make them.
But yeah, we try and like, it's really hard to like we'd have to have some like machine learning on people's applications to like know what people's intents are and stuff like that.
Yeah, that's perhaps too hard.
But maybe that's too hard for us. But it is like I said, documented in our documentation of, where you can say, forward a message or send to, and basically doing some computation and then returning something else and forwarding on. And the good thing about this is this does actually work with alternative Kafka implementations. We mentioned Kafka streams and K-stream and all that kind of stuff when you're really working in real official Kafka. But this stuff works with on, like, for example, OCI streaming and other implementations that are not yet, although I'm sure one day they probably will be compatible with Kafka streams, right? So I think that's pretty cool.
Since you mentioned platforms where it works, Micronaut is known to work very well with GraalVM native image.
Yes.
Right? Would I be correct if I assume that this naturally easily compiles to native image without any additional configuration much?
Naturally, yes, it does. So you can essentially run build native image, and that will compute the consumer into a native implementation that will can be executed natively. Likewise, the producer can do the same thing, and basically convert it into the native version of this application. So this process of, as you know, native image has to do all the number crunching and processing, whatever else, turning it into a native executable. And that can take some time. But yeah, once you have a native executable with native image, clearly your little message-driven microservices, you can have a lot more of them, right? On a particular hardware platform. And that's a great fit for the Kafka model, right? Kafka is about scaling, by essential processes. Now, you can scale by threads in Kafka as well. In fact, on the Kafka listener annotation, you can say, create more threads, more consumers. But really, like, scaling by processes is, each consumer occupying a thread, being a single thread, is it's more natural when it comes to Kafka. So you can have like a fleet of native consumers occupying very little memory, relatively consuming vast amounts of data, and all these folks that are like motivated by re-implementing Kafka in things like Rust no longer have to, right? They can use the same, it's, at least for the consumers. So yeah, I think it's pretty cool. Build a native image, and there we go. So my native image is built, and probably I can run. Maybe I should stop this other one. There we go. It's listening natively, and obviously that like started up way faster. And probably if we look at some of the stats on memory consumption with this guy, it's consuming what looks like to be 14 megabyte of memory.
Nice.
Which is obviously a lot more than a lot less, sorry, in the JVM version. So there you go, with my native listener receiving all of those messages. And even after receiving and processing those messages, memory consumption has gone up a little bit, but 21, but like hardly anything. Like the Java version would be consuming significantly more. So I think that's pretty neat that that you can turn all of these services into native consumers and native producers, and it all just works, right?
Right. Yeah. This is very cool. Because you can put those in like unexpected places then, right? Where like in the small devices which have like a little bit of memory, or you can utilize your hardware very efficiently by kind of stuffing more instances into the same amount of memory. You probably don't get that much on the CPU, though. There is a claim that if you don't need to JIT, and if all the compilation was done beforehand, then maybe you just do the exact amount of work needed for the processing of the messages, and then you can like pack it into your existing hardware and your clusters much better. That is cool.
Yeah.
That is cool. No, but what I like the most is that there is no configuration needed, and it's a perfect example of sort of a complex integration that definitely, right? It uses dynamic features, right? It serializes things here and there, right? And with the Micronaut support for the introspective things and the code generation, it all is taken care of. So that is very nice. You just can take it and clone the project and then use it for services.
Yeah, exactly.
Cool. That is very cool.
I think so, and it's a very popular module we have. I would say a significant portion of the Micronaut user base. Definitely, it's one of the more popular modules. In particular, in terms of messaging, it's certainly very popular, and people like the ability, the fact that like with this consumer, there's no like HTTP endpoint. It's just like listening to messages, but you still get access to all of the bits of Micronaut that you need, validation, Micronaut data systems, and you can build these message-driven microservices that are, very self-contained, don't expose any ports and so forth, and compute them into native images. So that's very cool, and the niceties that Micronaut adds in terms of making it a kind of declarative way to define listeners while still allowing you to access the underlying power of Kafka and so forth. I think that's one of the reasons it's pretty popular amongst our user base.
Yeah. And it certainly is very cloud native. Thank you very much, Graeme. I think this is now time to ask questions. Chat, if you have any questions to Graeme about Kafka or the implementation of the support in the Micronaut framework, now is the time to ask. We'll try to catch him with all the questions. Tricky questions can go as well. If you want to know whether Micronaut's support for Kafka better than Helidon's support for Kafka, now is the time to ask. I don't know. It's like no, don't ask that, right? We don't want to.
I'm not a subject matter expert on that topic. Actually, I have not actually tried Helidon's.
Right. You mentioned. Sorry. Yeah, you mentioned that Kafka is one of the more popular kind of packages, integrations in the Micronaut, which I think is because it's a lot of cloud native systems are built with this event-driven architecture in mind, right?
Yes.
So, and Micronaut historically has been sort of oriented and positioned, right, as a framework that it works very, very well for applications that are deployed into the cloud, so that there is a natural match. Do you know what is the most popular modules that you have? Like maybe not even Kafka related.
The most popular module is Micronaut data, sure.
Okay.
Give me a minute because somebody is ringing my doorbell, and I will be right back. 1 second.
Right. No worries. No worries. Okay, chat. Graeme is gone. You don't have any questions? That is interesting. I wanted to start saying goodbyes, but
sorry about that.
No worries. No worries. We are at time. We are past the hour. I don't see any questions in the chats. That's all good. So I don't think we need to make this session any longer. Thank you very much for joining us, and thank you very much for showing Micronaut applications. We did 3. You did 3. No, you did 2 applications and run one a few times. But yeah.
I think that, it was a lot. It was a lot of fun, and I hope people got some insights into what Micronaut plus Kafka is all about. I think we were talking about the most popular module in the Micronaut before I had to get up and answer the doorbell. It's definitely Micronaut data. Micronaut data is immensely popular. I think database access clearly is the most important thing to most developers. Micronaut data has a large number of stars relative, for a module. The other one that's really popular is OpenAPI. People love documenting their APIs. So that
really?
one is yeah.
I would think that only responsible developers love to document their APIs, and that the world consists mostly of not so responsible developers. But that is good to know. That is excellent to know. I assume metrics would probably be high.
Metrics is probably pretty popular. OpenAPI, I think, is popular because Micronaut makes it so easy, right? It just generates the definitions from Java. You don't have to do anything. Metrics is certainly very popular. Micrometer, many of the cloud modules that integrate with things like service discovery, the Kubernetes module is very popular. That kind of thing.
All cool.
So yeah,
I think we can for the future we can maybe look at one of those that we didn't look at before, or maybe a combination. That would be interesting.
Yeah,
that would be interesting. Anyway, thank you very much, Graeme, once again for the session. It was very, very interesting. If you didn't catch it live and you're watching this on YouTube, then please join the channels. Micronaut. There's a Gitter channel for Micronaut, I think, which is one of the main ways to reach out and talk to the other practitioners, right? And then you can find Graeme on Twitter. He's fairly active. You can ask various questions and get pointers to the resources. And there is also a larger team working on the Micronaut, so it's a community project. And there are other people doing things and integrations that are definitely very valuable, and you can learn from them as well. So with all that said and done, thank you very much. Thank you very much for watching, and see you next time.
Thank you.